This is a moments question from a CCEA past paper, and this one I think is from April 2021, and it's question 3, so we'll take a look in a second. It's from the A2 Applied Maths one, so let's see what they're asking this. Andrew and Stephen play on a seesaw. Andrew has mass M1 and Stephen has mass M2, and it's saying that M2 is bigger, so Stephen is heavier than Andrew here. The seesaw AB has length of 5, that's okay, and mass of 15. The pivot P is at the midpoint, that's alright. Stephen assumes the seesaw to be uniform and calculated that he should sit at a distance of X meters from the centre, so there's our X of the seesaw for it to balance with Andrew at A as shown in figure 2 below. Find in terms of M1 and M2, you can't see this, but find in terms of M1 and M2 the distance X. So just a quick diagram here. You could do the stuff up above, so that's fine, but we have our pivot here, and that's where I'm going to take moments in about the point P. This chap is here and his weight is M1, so it's going to be M1G acting here. We're assuming that there's 15G acting down that way, and then our wee distance here is X, and the other guy here, so it's going to be M2G. So taking moments about this kind of point P, so I'm going to go clockwise equals anti-clockwise. And again, some people like to sort of see the pivot sitting here and pushing that way. So that one's taking it clockwise, and that one then is taking it anti-clockwise. So it's going to be X times M2G. And then this distance here, that's going to be 2.5. 2.5 times M1G. The G's here are going to cancel, G in both terms, and then X is going to be 2.5 M1 over M2. They get rid of the wee decimal within the fraction here. If we times top and bottom by 2, it would be 5 M1 all over 2 M2, and that keeps things slightly more tidy. Part 2, when Stephen sits this distance from the centre, the seesaw starts to rotate about the pivot and his side of the seesaw lowers. Using this information, what would he state about the seesaw? Well, either he's heavier than he kind of thought he was, but the thing is, if he's this weight, then the centre of gravity of the seesaw mustn't be acting about here, it must be acting here very slightly, so the seesaw is not actually uniform. And then part 3, when Stephen moves to a point 0.4 meters from B, the seesaw rests in equilibrium. Find in terms of M1 and M2 the position of the centre of gravity of the seesaw relative to A. So we need a new diagram. That then is our point P. We still have here M1G acting down here. Here, slightly further across, we have an M2G, and then if it's going down on this side, then the 15G must be acting round about here. This is the point A, this is the point B, and they want us to find in this distance here. So I'm going to call that distance D, and then that's kind of what they've asked us for. So we're going to take moments again about the same place. So taking moments about P, and we have clockwise equals anti-clockwise. So you need to be careful of this first one. Let's do this one first, it's a wee bit more straightforward. What we've realised is that's not 0.4, so it means if that was 2.5 take away 0.4 gives me 2.1, so that distance there is going to be 2.1. So that's going to be 2.1 times M2G plus the 15G, right, this is complicated as well. So that distance is d, but I want the moment from this point here. This is my pivot point. So the moment's going here, and it's just that wee distance there. So if that's 2.5 and that's d, then this distance is going to be d take away 2.5. There are other ways of doing this, but because they've asked this relative to a, I think this is the most straightforward way. I'm not entirely comfortable with it. Sometimes you could call this a different letter, like e or something, work it out, and then find the d relative to it at the end. And that's that then times our 15g. So those are the two that are pulling it this way. Those are two clockwise ones. The anti-clockwise one then is going to be 2.5 times m1g. Again, we have a g in each of our three terms, so they can cancel. And we're asked to find d effectively here. So let's start tidying things up. So it's going to be 2.1 m2 plus 15d minus 37.5. So that's the 2.5 times the 15. Let's be multiplying out the bracket effectively times that is equal to 2.5 m1. We want the d on its own, so I'm going to take these two over to this side. So my 15d is equal to 2.5 m1 plus 37.5 minus 2.1 m2. Now divide by 15. And I suppose then just again with decimals in with our fraction here, so that's times top and bottom just by 10. So my distance then is 25 m1 plus 375 minus 21 m2 all over 150, and that then is in meters.